So the first thing you do is to open your case from OpenFOAM. I have my foam file already ready, and I choose my case type to a decomposed case because that's how it is for me. I click apply, and I have my case already ready, and I'm interested in looking at the Vorticity element of my case. So I click on Vorticity, I change this from magnitude to Z component, and in order to make this look very pretty, there's a bunch of things you need to do, and the first thing you do is to add some nice grids. So scroll down here from properties, go to axis grid, select it. It doesn't look nice, we could make it look nicer. Go to edit and click on color blackface, grid color to black, and okay, and apply. So once you have that, you need to remove these things on top. That's not something that you need. So to get that out of the way, you could go down to access to label and uncheck all these things, click apply. Now it looks nice, but it can be a lot better. So to do that, you could go to the title text, add some LaTeX here, so $, frac, curly braces, XD, do the same thing for Y, and also increase the title font a bit to 20 and apply. Okay, that looks nice. We could also make the numbers look a bit more bigger as well, so make it 15. 16 looks nicer, I think. Okay, that's perfect. Now since we have our X and Y, this triad has no purpose. I'm sorry, but you have to go. So click on this and that disappears, and this is a bit awkward. And how do we center this? Well, this is fine, but it is still a bit janky. So to make sure it's fixed, go to this specific thing over here, edit color legend properties, click on that, uncheck auto orient, click on horizontal and upper center. You should have this. Apply. Okay, that's a bit more nicer, I suppose. And once again, LaTeX comes to the rescue. $, omega, that's how it's represented, Vorticity. And you can remove this Z component over here, and of course bump up the text a bit. Apply, and okay, perfect. But this still looks kind of ugly. It's not nice. You can barely see what's happening here. So to fix that, go to the top left hand corner. You should see these 4 green arrow icons over here. Click on the one with the eye. It becomes a lot more visible. That's its whole purpose. But you can make it look a bit more nicer. One more mainstream way is by normalizing the data first and then changing these things. But we don't know how to do that. We can always guess some random numbers to make sure it kind of fits. So I'll put in here minus 0.005 to maybe perhaps 0.005, make it look equal. Okay, that's perfect. This is of course just trial and error, just throw in a bunch of numbers, see how it comes out. And let me click on some other frames. Okay, looks nice, but this is still not that pretty. How do we make sure this is white? Because nothing is going on here and you would like to discard that information. So click on this light bulb, disable the light kit, scroll over here, and you should see these 3 values. If you're on the blue, white, red colors map, edit the middle value, which is the value that corresponds to the 0th value for now, and change it to 1 and 1 and 1. All the RGB values are to 1, which means it's white. So now it's white and looks nicer. But this looks like ketchup, and that is an ugly color. So we'll change the color space to one of lab. Okay, that looks a bit more nice. But now, how do we add those beautiful contour lines? Well, the issue with ParaFoam is that, ParaView it's not really an issue. It's the fact that you cannot add contours unless the value is scalar. And we know Vorticity has 3 components, so it's a vector, and that doesn't register with contours. So to fix that, we'll convert the Vorticity Z component into a scalar value itself. And to do that, go to test.foam and add a filter to it. Go to alphabetical and go to Python calculator. Click on this and type this out, Vorticity, that is what we need, and colon, comma, 2, and we get this. Change the name to scalar word Z. Okay, that's perfect. So we'll do that. Now go to scalar word Z. You should see there's nothing here because it's a scalar value. Once again, change the color region to 0.05 and 0.05. Okay, and of course modify the RGB values. Okay, perfect. And yes. Now to get the contour looking good, we need to make sure that's a 2D case. Though it looks 2D, OpenFOAM doesn't have any 2D cases by itself. It is inherently a 3D case. So in order to make it 2D, click on slice over here and go to Z normal, apply it again. Of course, it resets everything. Scale Z. Make sure it's 0.05. And rescale this. And now we can add the contour filter finally. Click on this, contour by our scalar word Z. Remove the value ranges for now for the ISO surfaces. And to generate a number series, give the same range as you gave before. Press generate and apply. Now this looks pretty, but this isn't what we needed. So open slice again. It doesn't look pretty at all. So go to contour. And you could change the contour by editing this specific thing, coloring over here. Click on edit. Okay, never mind. Change the contour color scheme to based on solid color, and then click on edit, and then choose it to be black. Okay, perfect. Looks a lot more nicer. Of course, the color bar you could again go through the whole same exercise as before, but I'm not doing it again. So we have that, and it looks nice. We could add some more definition over here. So delete the whole contour thing again. And for the number of samples, maybe make it even, make it 20. So just do that. And this, of course, changes a slice. Let's change that, make it this. So we get the original color scheme back again. Okay, that looks a bit nicer, I suppose. But CFD stands for Colorful Fluid Dynamics, and there's not many colors going on here. It's just red and blue. So let's make it more colorful. To do that, go to Slice, change the color map to something more colorful. So click on Choose Preset. You can see this hierarchy over here, and this should open up. For me, it's a bit slow, but you shouldn't have that issue. So you see a bunch of cool colors over here. So we could choose maybe Turbo perhaps and apply that. Okay, that looks nice, but not too amazing. A more standard color is Jet. So change this to all and type in Jet. You should see this, you shouldn't see this. I'll explain that a bit later. Press on Jet and press apply. Okay, that's perfect, I suppose. But I have a personal vendetta against the color green. I think it looks not that great. So we could make this green white and make it disappear. So go to Slice again and choose Preset again. Let's type in Jet. Now, in order to modify this to be a white color scheme, you could do the same thing again and do the whole 1, 1, 1 exercise. But it isn't a pure white color. There's some yellow hue over here. To fix that, you need to manually edit the color map over here. So once again, go to Preset. Now, once you click on this preset, press export. And what it should do is open a JSON file, which you could save and modify. So I already have the JSON files open here. Let me drag and drop. Now this is how it looks like once you export it. You should see the color space, which is RGB, default map true, name jet, and these are the RGB points. So there are like, I think, around 7 values. There is -1, -0.7, -0.2, -0.1, -0.2, -0.10. Okay, there are 7 values here, and these correspond to the 7 value points for which all the RGB values are specified. You could modify this to have maybe 8 points and then have 2 centers. I mean, not 2 centers, but you get what I mean. So I've done that, and I already have this specific thing going on. I have -1, and you notice I have this 2 values in here. These are just white color schemes, and we have the cyan, blue, and deep navy, and we have the red and dark red, which correspond to the red scheme. So you could take a snapshot of this and perhaps use it yourself, or you could modify something on your own. This is something that I found. So once that is over, you could go back and import the JSON file, and you should get something like this. So let's press apply over here, and wow, that looks so much prettier than before, no? That looks so nice. Okay, that's perfect. So we'll just edit the range files again, make sure it's 10 so we don't have that many things going on. 10, add, generate, and apply. Again, slice gets modified, and 0.05, and that's it. And that's it. That is how we get those beautiful plots. Everything looks nice and clean and pretty, most of all. Look at those beautiful vertical layers. Amazing. Okay guys, that is how we get those cool plots. And let me know if any questions. Thank you.